Question 1. Below is a graph of f of x. So below is the graph of f of x. For each of the given points, determine the value of f of a. The a's are given here. This is a, we go down and play that. So each value of a, for example, -5, find the f of -5, find the limit as x goes to a from left, from right, and then find the limit itself. If n of the quantities do not exist, clearly explain why. So you are given this question. Now you're used to functions written for you. And then they ask you to sketch. Now they have sketched for you. And then they ask you to get solutions from the sketch. Like that. So, for the first one, we are talking of f of we are talking of f of f of -5. So, okay, let me go to the plain board. Okay. F of -5. So we're starting with f of -5. A f of -5. So we're doing a is equal to -5. So what is happening there? Well, if you look at the function itself, at -5, we have a graph. -5 is here. And then we have a point at -5, 3. Like that. And then, of course, we have a graph that is coming like that. And then it's open there. And then going down like that. In fact, it's not reaching that far. It's going down like that. Where that point is direct here. So this is -5. So this is -5. And we have a point there. Then they ask you to find f of -5. Well, they just ask you to complete the point. I mean, -5, what? This point here. Because up there it's open, so you can't say there's -5 there. So it's -5, 3. So f of -5 is equal to 3. You are done there. Then you find the limit as x goes to -5 of the function f of x. What we mean is the values of x will be coming down if we have -7. So -7 should be -7, -6. As the values of x are going to -5, what is happening to the curve? What is happening to the function? So the function is going up. It's going up. Going up. That number there is 7. So the function is going up to the value 7. So here we are saying 7 from left. Again, you check the limit as x goes to -5 from right, meaning this time around, as you go to -5 from this direction, okay, if I have -1, -2, -3, -4, what is happening as the numbers are getting closer to -5? Well, the function is going up to +7. That's the analysis there. Well, you keep looking at, you hold on the x and go closer to -5. The other hand is holding on the curve. As I get closer to -5, which number is it getting closer to? And you can see the curve is going, spiking high to 7. It almost reached 7, except it's just undefined at that value. So now before we are done, we'll go through. So for you to find f of -5, you just go to the value of x, -5, and look at where it is defined up. Here we have a full point against 3. So it means f of -5 is 3. We can't say it's 7 because it's open there. So we can't use 7. We use where it is closed. Okay, and then to find the side limits, you're just following the directions. Then the other question says, now that you have found the side limits, are you able to tell us what the limit as x goes to -5 of the function f of x is? If these two are equal, then it means they form the limit. If these two were not equal, then the limit was not going to exist. Would have said the limit here does not exist. Okay. So we take note.
So, sir,
yes.
So even that point which is there is part of the function.
Yes.
Okay.
It is actually what is part of the function. So why are they calling them limits? It's like they are almost boundary numbers. So just want to say, what is the boundary for this as this is happening? Which whole number, in simple terms, they're just saying which whole number would be the end of this as we get closer to this number. That's like the main purpose of the everything. So what are we taking note of? Note that one, the limit as x goes to c of f of x exists if the limit as x goes to c from left is equal to the limit as x goes to c from right of f of x. Otherwise, the limit does not exist. Like that. And then, on which of these points is the function discontinuous, and on which points is it continuous? So maybe we should answer it for -5 now. So we say, well, at -5, at a is equal to -5, f of x is not continuous. Meaning it is discontinuous. Okay. So meaning it's discontinuous. What's the reason? Because the limit as x goes to -5 of f of x is equal to 7, which is not equal to f of -5, which is equal to 3. So then what does that mean? Take this seriously now. F is continuous at X is equal to C if 1, F of C is defined, 2, the limit as X goes to C of F of X exists, and 3, the limit as X goes to C of F of X is actually F of C. That's when you say the function is continuous. Otherwise, the function won't be continuous. So to be defined, we have found the number 3. The limit to exist, the side limits are equal, and so the limit exists here. But is it continuous? You check if the number you got here is the same number you got as the limit. If the two are different, then you say the limit, the function is discontinuous. It's not continuous there. Okay. Then we have another point. Another point, -1. I mean, -1, 1. So B, we're checking at A is equal to -1. So again, you start first, what is F of -1? So you go to -1 and look at what -1 is giving. So what point do you have? We have a point -1, 1. So this will be 1. Then 2, what is the limit as X goes to -1 from left of F of X? Well, this one from left and right, we're getting the same number 1. Because it's just a curve. So I'll write the limit as X goes to -1 from right of F of X, which is telling us that because the two are equal, this means that this exists and it is equal to 1. Because the side, the left and the right are equal, then the limit exists and it is equal to 1. Then 3, well, because the limit as X goes to -1 of F of X is equal to 1, which is the same thing as F of -1, then F is continuous. It's continuous at X is equal to -1. Just following those steps. So you check first if it is defined there. You find the number. Then look for the limits. Left and right, if they are equal, then you have the limit itself. Then from there, you check if the limit that you got is the same thing as the value of the function at that number. Okay. Then we complete the graph. It's open there. It goes up and becomes open at 4. It becomes open at 4. And then it comes down. Command B open here. Comes down. Command B open here. And then it goes back up. Like that. In fact, it didn't go very far. Yeah. It ends somewhere there at 2. And then it's touching here at 3. And there it's touching at 5. And then 4 is here. And this is -2. And that one is 4. And then this is 1. Then now they ask, what is happening at 1? So we want to check at A is equal to 1. So first thing is, well, what is f of 1? And there is f of 1 is given up there. It's happening somewhere here. We have a cross dot at 6. So when they say 1, find f of 1. Well, you just follow where it's closed. You can't come here, it's open. You can't go there, it's open. So you go where it's closed. And so we'll say that is 1,6. So the answer is 6. Second, get the limit as x goes to 1 from left of f of x. So you check which line is going to 1 from left. Well, we have nothing here from left. We have this line here. Is 1 coming to, as x is going to 1, the curve is coming down to -2. So it means our answer becomes -2. Okay, and the limit as x goes to 1 from right of f of x is, as x goes to 1 in this direction from right, the function we have is going up to 4. So you say there it's 4. Oh, and because this number is not equal to this number, then the limit as x goes to 1 of f of x does not exist. Like that. And so if it doesn't exist, well, then f is not continuous. F is not continuous at a is equal to 1.
Excuse me.
Mhm.
How did you get 6? And how are you supposed to know if you're supposed to use the graph in red or in black?
So when we say from left of 1, you understand that this is the left and this is the, so this is the left and this is the right of the number 1, is it? So if they say the limit from left, negative up there, meaning you check from left direction, and you can see that from left of 1, if I block 1 here, if I block 1, from the left of 1, we don't have the red line, is it? We have the black one, so that's why you know I'm using the black one. And then from right, we have the red one. We don't have the black one, so you know I'm using the red one. Yes. And then how do you know you're getting, how are you getting f of 1 to be 6? Well, it's a point. We have 1,6. This point that is shaded here is 1,6. There's nowhere else where we have a closed dot apart from at 6.
Oh, the thing is, I considered even the open one.
No. The open one, there's nothing there. It's open.
Okay. Then
okay, did I get
just
that?
one last one. How are you supposed to know whether you're supposed to go above or below? Because on the red graph, it's made something like a V. So how are you supposed to know that you're supposed to even get from below?
No. The question is, as we go closer to 1, so we're looking for 1. So even if you came this direction, you haven't found 1 here. So you go. We're still coming until we get to the value that is coming from 1. Well, this is coming to 4. There's 4 here. Then you still have, there's 3. But we're talking of 1. So you proceed until you find information about 1.
Oh, all right. Thank you.
Okay. What was the other question?
Yes, what if that point at 4 from the red graph was also a shaded point there, was defined there also?
It's not possible.
Not possible.
Like if this time as we are talking right now, me, I'm teaching from the room, from within campus. On answer 427. You can't find me at the ground this same time. I'm in the room. So if you go at the ground, you won't find me. If you check in your room, I'm not there because I'm here. That's how impossible it is for you to have two values closed, different. No. If that happens, remember, if you go back to functions, if you have A, B, and you have C, is this a function?
It's not.
This is a function. But the one that fails to be a function is this one. I have A, it gives me B, it gives me C. So this is not a function,
Oh, yeah.
right?
Yes, sir.
So you can't have on the graph, they shade there, they shade here, and then they call it a function. It's not a function because if this is 1, it's giving us 2, it's giving us 3, it's giving us -2, meaning we'll have 1 alone, giving us -2, 2, 3. So it will have this. Then you call it a function. How? It can be a function that way. So that's why you are saying it's impossible for that to happen. Let me answer this other question. What's the question? Why is -2 considered if it's open as it approaches 1? When you got the limit, you don't care whether it's open or closed. For as long as it's the whole number that you are getting closer to, then that's the one you pick, even if it's open. For limits, even if it's open, if you look at 7, we got 7 as the limit as x goes to -5, but it was open there. The same thing happens at -2, even if it's open, but that's the number we're getting closer to. Yeah, I've answered quite a good number of queries. Good. Wonderful. Next. So for limits, answers are always in the Y's. Yes. You're looking what is happening in the Y because you're controlling the X. So as I move X closer to this number, what value of Y is coming in play? Then G at A is equal to 4. So we go back and check the graph. Have you seen that it's open at 4? And there's nowhere else where it looks like it's closed. Why can go as Y goes to 2? No. There's nothing like as Y goes to 2. It's everything like as X goes to 2. And then you check what Y is becoming. That's our limits. So if you look at 4, the only thing that we can see is an open hole there at -2, but there's nowhere where it is closed. So this means that the whole line X is equal to 4 is a vertical asymptote. So we're saying 1 f of 4 is undefined. And then 2, what about the limit as X goes to 4 from left of f of X? Or you look at the graph from left, and the same red line is not giving us the information. It's going down to -2. And also on the right, it's coming down to -2. So I get to -2, which is the limit as x goes to 4 from right away from x. And then 3, you want to check if it's continuous. Obviously, so because we're getting the same thing, we're saying, oh, the limit here exists. So the limit as x goes to 4 away from x is -2. But unfortunately, f is not continuous. So f is discontinuous. At a is equal to 4 because f of 4 is undefined. Remember, it must be defined. It must be defined. The limit must exist, and they must be equal. So now, one has failed. So we can't even compare if they are equal. Okay. Wow, this looks like something that can be pressured to be done in a day, but there's nothing like that. Finish it. So above an exercise. Submit before base 12. Submit before 13/09/2022. Before, which one am I supposed to submit? Supposed to start with time. So submit before. No, I don't have class. Okay, so submit before 23 hours. 1. For 23 hours, which date? Of the date 13. Yeah, 09/2022. Question 2, sheet 9. So I need this. It's exactly like question 1, except there's a different graph there. So please don't lie. Don't start telling me wrong solution that it's a correct one. Don't lie, don't lie. Don't lie.
So
Okay.
where did you study solving for C and C property?
C was just a
Yes.
squeeze somewhere. Yeah, C was there. In red.
Okay, sir. Thank you.
Okay. So we rest for let me see. We need to rest Then no need to rest. So let's just, so this is just cutting here and immediately we join. It cuts, you join immediate. Not going to wait.